Okay, so what I want to talk about today is about the electric charge, and also I want to talk a little bit about the forces. In this case, it's electric force. So first, I want to focus on the electric charge, and I want to in this material it explains why after you rub a plastic roller on your hair, then you bring the ruler closer to your head or arm. It can make the hair on your head or arm stand. Or if you put the same charge, the same object, charged object, and uh, in this case, the word charge is a term that we will use very often later on. So if we use the same charged ruler closer to water flow from the tap, it can attract and bend the water flow. So it's like this is a tap, and that's a lever, and without the object, it just goes straight down. But when we put a charged object like this, for example, this is the charged lure, charge. It will not go straight down like this. Instead, it will be like it will bend closer to the charged roller a little bit, then go down. And that's what we're going to focus today to explain why this happened. Or if you, interesting part, if you have a long hair or kind of long hair, when you touch a find the graph generator. If you haven't, you have never done it, try it. When you do that, your hair is going crazy. So all of this event, like this water flow that bends after a charged object is put close to it, it can be extremely. No, it is about the electric charge. That's how we can explain this event. That's why we're learning about electric charge. And this electric charge thing, it also explain about how the electronic devices works, or what electricity is actually. That's all about electric charge. So here's what we're going to do today. So we need to understand about electric charge. So we want to explain what electric charge is. And then we want to talk a little bit about electric force after that. So first, we're going to talk about the electric charge. So to explain about electric charge, I want to liken electric charge, or I will just say charge for now. Charge and mass. I want to I would like to liken those two. So every object has mass. So is charge. So every object also has charge. And actually there are two kinds of charges. The first one is the positive one, and the second one is the negative one. To remember this. This is how I remember this. So if you notice in the electronic devices, they have cable, and to power that electric devices, they use at least two cables. Maybe sometimes they are wrapped in one, like this one, Like this one, actually there are at least two cables inside, but they're wrapped as one. Or sometimes in the plug, there are two metals that are sticking out. Why they use two cables, or why there are two, at least two metals that are sticking out? Because there are two kinds of charges, that is positive and negative. So if you're familiar with atom 2, mass and charge are related to it, but we're gonna talk about charge now. So if we talk about atom, in atom it has, for example, the simple one, just with one thing inside, one proton, that's what it's called, the proton, and one electron that is orbiting the proton. That's the simplest atom. So in atom, the proton that is located in the middle, it has positive charge, and the electron has negative charge. So the charge of an object is really related by the amount of electron and proton together. And another knowledge that you need is that two like charge will repel each other, but two unlike charge will attract each other. For example, if we have one positive charge here and positive charge here, they will repel. So that if we have negative charge and negative charge, they will also repel. However, if we have one positive, one negative, no matter where they are, the negative can be on the left and the positive can be on the right, and they will attract to each other. So we have learned about two kinds of charges and about the atom and how the atom or how the electron and protons can or is related to the charge of an object. So for the next one is that about the neutral charge. Neutral charge means that the positive and the negative, they're equal, so they cancel out. For example, let's try this. Uh, we we already learned that the charge of an object is related to the positive or electron. Oh, sorry, the negative charge or electron and the positive charge or proton. Each of these subatomic particles, they have what is called electric charge that is measured in coulomb. Coulomb. We'll write it here. Coulomb. So one electron, I will say like 1e, it has charge negative 1.6 times 10 to the negative 19 coulomb. Or usually we can write it as negative 1e. That's okay. For one proton, it has charge, I will say proton P. It has charge positive 1.6 times 10 to negative 19 coulomb or positive E. Actually, they have the same amount of charge. So if we look at this, if we have one proton and one electron, the amount of the positive is positive E or positive 1.6 times 10 to negative 19 coulomb, and the negative is negative E or negative 1.9 times 10 to negative 19 coulomb. So the amount of positive and negative are equal. So we say that this atom is neutral. So we say that to like objects that repel like objects, and to unlike unlike object to unlikely charged object, positive or negative, they will attract. So how about if we put something to neutral charge? The answer is it will also attract. Why? We'll talk about it later. But now I want to focus about how we can um, calculate the net charge about an object. So we say that that the charge of one electron is negative E and the charge of one proton is positive E. So I have some problems. So problem number one, let's say that I have two, I have an object with two electrons and two protons, and I want to calculate the total charge of the object. So we know that the charge of two electrons, I will say that it's QE equals to negative 2 times, I'm sorry, maybe like this, 2 times, because we have two of them, and the charge of one electron is negative E. So QE, the charge of electron total, is negative 2 electron. The charge of the proton, same as the electron, it's 2 times the charge of one proton, which is positive E, which is positive 2 electron. And to calculate the Q total, we will add them together. So QE plus QP equals to Q total, and this equals to a negative 2 electron plus 2 electron, 2E, which equals to negative 2E plus 2E is 0. So since we know that is equals to 0, then we say that this is neutral. That's what we learned earlier, that when the positive and the negative are equal, then it's neutral. Or from this we'll learn that it's neutral when the charge is 0. Question number 2. So let's say that I have an object with 2 electrons, and now instead of just 2 protons, I have 10 protons. And let's see what's the total charges. So the Q electron is 2 times negative E, which is also negative 2E. And now the QP equals to 10 times positive E, which equals to 10E. So we add them together. QE plus QP equals to, this is what we call Q total, and this equals to A electron. So earlier we talked that 1E equals to 1.6 times 10 to negative 19 coulomb. So if we want to convert this into coulomb, what we're gonna do is to multiply this one by conversion factor, which is times 1.6 times 10 to negative 19 coulomb over 1E. In this way, we can cancel the e's, and the answer will be 12.8 times 10 to negative 19 coulomb, or 1.28 times 10 to negative 18 coulombs. That's how we calculate the net charge of an object. So number 3, this is your homework actually. How about if I have an object with 132 electrons and 120 protons? What is the Q total or Q net in electron and coulomb? That's the homework. Okay, so that's how we calculate the charge of an object. Let's talk about how, let's try to explain about how a neutral object is attracted to both charges. So to explain this, I will again use the example of a tap and the water flow from the tap. And there we bring a charged object. Let's say that it's a negatively charged rod closer to this water. Negative. What will happen actually, we know that this water is neutral. And we learned before that neutral means it has the same amount of positive charge inside and negative charge. So when we put a ruler, negatively charged ruler closer, what will happen is instead of just staying neutral, no, it will stay neutral, but over here, the position of positive and negative charge is just randomly positioned. But right now, since we have a negative charge rod over here, we learned that the likely charged object, or in this case, negative and negative, they will repel each other, but negative and positive will attract to each other. So this one, in this water flow, actually what will happen is instead of the positive and negative are randomly positioned, the positive charge will be attracted to the rod. So the positive charge will move to the right, closer to the rod, whereas the negative charge, the electron, will be pushed further from the rod. In this case, the positive charge will all be on the right side, and the negative charge will all be on the left side. Because of this, then the water from the tap will bend toward the ruler, since on the right side it's more positive now. And if you want to know, this is called that this water is polarized. Now what I want you to try is to explain. So at the beginning I told you that when you touch the Van der Graaf generator, your hell will go crazy. I want you to explain. It is the same concept with this one, but I want you to try to explain why it happens that way, how it works, and that's your homework. And the next one is about the force. So earlier we learned that the likely charged object, positive and positive or negative and negative, they will repel to each other. and the unlikely charged object will attract to each other like this. So since there is repulsion or attraction, there must be what is called force. So Coulomb say that between two charges there is a force. It's the same concept when we talk about the gravitational force. So gravitational force happens or is created by two objects that has mass. This one is gravitational. And then when there are two objects with masses, they will attract to each other. But now we're going to talk about charged object. In charged object, the force that exists there is called electric force. And in electric force, unlike the gravitational force, it can attract or repel. It can repel to each other. So, how do we know when it attracts and when it repels? Well, the same thing, like this one. Two likely charged object will repel, and two unlikely charged object will attract. It's the same thing. And now we're interested not just to how it attracts or repels, but how to calculate it. So how to calculate it? Coulomb came up with a formula that is that electric force equals to some constant, Coulomb constant, times the magnitude of the first charge times the magnitude of the second charge over r squared.